cap. Look at that. Mark's doing some
Yeah,
3D printing.
check this out.
It's pretty far out.
Hawthorne, New Jersey, when SpaceX is in Hawthorne, California, but we do have the SpaceX hat.
What happens when you lift the helmet down? Do you get special powers?
I could sense something coming through. Maybe that's the third eye.
Got to get a visor for it. But
with a helmet like that, you look like you got a third leg,
hard
mate.
To 3D print, clear visor, and it also messes with my head, so my hair.
Right, got the helmet hair. Not
space hair. That's what that is.
That's right.
Phil, how you doing?
Hey, pretty good yourself.
Good. Before we went live there, you're talking about how you just finished your paper and submitting it. Did you want to discuss that a little bit?
Yeah, I'm gonna share my screen and talk about for maybe 5 or 10 minutes, if you don't mind.
Yeah, for sure.
Share screen.
Present at the bottom, yeah.
Entire screen, all right.
Oh, there we go.
So that's my experiment for those that didn't see it yet. That's a liquid metal vortex that I'm working on right now. I bought the liquid metal from China, but it takes forever to get shipped. I required some assistance from a Chinese friend because to speed things up, let's put it that way. I'm 3D printing the apparatus at the same time. Hopefully that's going to be done this month. And I've got the whole electric circuit design ready. Everything is ready. Theoretically, I just need to put everything in practice and not short circuit the whole thing. So my experiment is ongoing right now, but it's slower than I expected. That's actually it's a strange timing because today I just submitted my manuscript to General Relativity and Gravitation Journal for peer review. I'm actually rewriting the whole astrophysics, the whole universe from the macro scale to the high energy physics. I talk about you can see the energy of accelerated particles here. There's a slight difference with relativity and finite theory. I'm talking about the gravitational redshift. I'm explaining the gravitational potential, all the physics. It's not just a mathematical abstract anymore. I'm explaining everything. The perihelion precession, disparity, the light bending. Here, the gravitational potential right here. It's very simple. The redshift here, it's all like algebra, calculus. I don't need tensor calculus at all. It's very simple. Here's the redshift, the gravitational redshift. Cosmological implication. The moon, there are anisotropies with the light. There's a lunar laser ranging experiment. They send a laser on a mirror on the moon that is reflected back to the Earth, and they notice that the light is not always going at speed c. So it's the motion of the planet plays a role in it. So there's an anisotropy of the speed of light there. And it's been noticed at the macro scale with supernovas and all that stuff. So, and here I'm calculating the correct distance we are from the moon using finite theory. And I calculate that we're 7 meters off what general relativity predict. I'm explaining the flyby anomaly, the invisible universe, the Planck linear mass density, the galactic rotation curve. I applied finite theory to 500 galaxies, and I get the exact rotation curve for each one of them. So it's right on spot. I've got this is just a sample here, but I've got a software that I wrote that processes 500 galaxies in 10 minutes, something like that. It's all C++ code. And here I calculate the distance we are from the universal core, the center of the real universe. I call it the universal core. Here I talk about the energy density. I calculate a whole bunch of important stuff with simple algebra. It's really high school algebra right here. And it's based on the mostly based on what was disregarded for so long is the gravitomagnetic and the gravitoelectric fields. You just interchange one with the other, and you can find the Hubble law, for example, is really just the gravitomagnetic field, and you can convert it into the gravitoelectric field, which is the gravitational acceleration, and you can retrofit the distance we are from the universal core from that. So it's very simple. I mean, it was very hard to figure out, but at the end of the day, it's very simple to represent. Here that's my experiment proposal that.
So you've essentially connected electromagnetic energy with gravity and mass, correct? Within the...
Yeah, I'm doing the analogy. Well, it's not an analogy. It's like I'm doing the, there's the electromagnetic force and there's the gravitoelectromagnetic force. The electromagnetic force, the gravitoelectric force is just regular Newtonian acceleration. Like, A equals G times the mass divided by...
So you're providing the groundwork essentially of bridging general relativity into electric universe theory.
Yeah, it's
that's pretty cool.
I don't invent anything, by the way. These are all existing formulas. Here you can see I'm using the Newtonian acceleration right here at equation 118. And from there, I calculate the distance we are from the universal core. So, I really don't invent anything. I just revisit the fundamental equations. So, but it's mostly based on, and I think the main equation, what you're asking is this equation. One sec. Yeah, this equation right here, 112. That's the energy density, the electromagnetic energy density. It's this formula right here. But I'm doing the exact same thing with the gravitoelectromagnetic energy density, and I am able to solve a whole bunch of like the size of the real universe. We are actually moving. The visible universe is moving, and we can already see what we see very far away is a bubble multiverse. It's other universes we are already able to see. So yeah, so we can see our own universe, but we can already see neighbor universes as well. So it's
That's pretty cool.
yeah, it's. I wish I have a presentation that I showed at APEC. Maybe people can check it out. I'll try to post the link again.
For sure.
And this is the ISS International Space Station experiment proposal. It's just the way it's just consists of doing the Michelson Morley aboard the International Space Station, because the International Space Station goes 3 times the speed of sound, which is sufficient to measure a small discrepancy in the wavelength meter. So we should be able to see it, but the experiment is right there, and I've been proposing it for years, but I've been talking to
Never get a straight answer from NASA.
Yeah, well, I talked to the cases, the Center for Advanced Science, the group that handles the research on the International Space Station. I talked to them, but they said I need to pay like $500,000, and because it's too complicated for them, they can't really give me a grant for that. But it doesn't matter. They already have other ways here. It's so convincing, the theory. I already get the rotation curves right here. I've got the earth tides and the flyby anomaly. I explain all that stuff. It's very simple to explain. So for me, in my head, it's not necessary, but to convince other people, maybe I'll need to do this experiment one day or the other. But for now, anti-gravity takes over, and it's more important, obviously. And yeah, but regarding the free energy, to go back on the main topic, today's main topic, I figured out that the Larmor formula kind of converts accelerated ions into radiation. So if you have electricity in a coil, the electricity is constantly going to accelerate because it spins in circle. So it's going to create radiation, and I calculated that this should be pretty significant. So if you want to create free energy, it's not free energy, but it's a pretty significant amount of radiation. The radiation is going to be perpendicular to the coil as well, so it's going to be in a straight line, which is pretty great. You can do. I already know what to do with that. I will do the experiment one down the road myself, but I know exactly what to do regarding that. There's also the piezoelectricity that is pretty cool. It's kind of a ribbon of diamond, some sort of diamond that creates electricity. Actually, I've got the presentation here.
I'm going to be showing you how.
Yeah, with this device here that just flips, he creates it. Actually, he's sending, and he's doing the opposite. He's sending an electrical current in the ribbon, and the ribbon kind of flips. He creates a fan with that, but you can do the opposite.
That's
You
an
can do
electroactive polymer, right?
yeah. You can do the opposite actually by flipping the ribbon. It's going to create electricity. So what I was thinking of is you put like tons of ribbon in the ocean at 45 degrees, and the waves are gonna, well, the internal waves are gonna constantly move the ribbon, so it's going to create electricity. So that's a pretty efficient way to create electricity. In 3 dimension, it's not like just on the surface of the ocean, but you can go in depth in the ocean and take advantage of that. And I saw also that some guys, I didn't double check that. I'm not sure if it's true or not, but there's a group of people, they claim to be able to magnify electricity. Their website is called Tesla's Power Magnification.com. They got a DVD and all that, so they claim to be able to amplify electricity like by 5,000 times,
Yeah.
5,000%. Sorry.
They've been on like Aaron Maya Makamaxi, I think his last name. Aaron something. He works with Eric Pollard a lot, Eric Dollard a lot, and does a yearly convention where these two guys met, and that it has to do with the reshaping the electromagnetic field of the motors or the generators, I think.
Yeah. Okay. Yeah, I don't know. I didn't check the theory at all. I think their name is Jim Murray and Paul Babcock. But I don't even know if it's patented, their stuff. Yeah, apparently it is. But just a heads up here. And there's also this cool new thing: 100 years of power using H2 boron plasma fusion breakthrough. I didn't go through this article, but yet, but it's pretty convincing. And last but not least, their Caltech, they have a satellite that is able to convert to beam down solar energy on the surface of the Earth. They're currently testing it, and they're pretty. They said, I think they wanted to commercialize it this year if everything goes well. So they have I don't know exactly all the technical details, but they have some way of converting the solar energy and beam it down on the surface of the Earth. So so
Could either be really good or work out really bad.
yeah.
Well, I
So,
see it's
yeah.
really efficient because it doubles as a weapon.
Yeah, right? Like,
Yeah, I want to share all that stuff, and hopefully I didn't step on anybody's toes here with my.
no, that was awesome, Phil. Appreciate it.
Cool.
Really good stuff. Well, I've got your paper downloaded. That I'll give it to read over more in depth afterwards, and we'll talk more about this for sure. Like, have a follow up, as I'm sure Simon's also definitely going to be reading that as well as many others.
Yeah, but it's being peer reviewed right now, and peer review is very subjective. Sometimes just because they don't like the color of your graph, you can be rejected. So, but I corrected it multiple times. I had help from Pablo, in the WhatsApp chat, so he's very helpful. And William Ricken too. And but yeah, I'm pretty positive, man. It's gonna move forward, man. So hang in there. Yeah,
Nice. That's awesome, my friend.
cool. So yeah,
And
that was my
congratulations on the peer review.
yeah. Sorry.
Congratulations on submitting it for the peer review, and hopefully it goes well for you and they don't find a random excuse to hate it.
Yeah, yeah. But I'm pretty optimistic because I cover everything, man. I don't neglect anything. I talk about everything, so I'm pretty optimistic.
That's the best way to be.
Yeah. So yeah, that was. If you guys have any questions, go ahead. Otherwise, we can move on to the next the next candidate.
Yeah, Mr. Mark, you were doing you've got someone helping you with setting up some extra coding, you were saying down there today. And what else are you working on at the shop? Oh, you're muted. Sorry. You got it.
You want to get a good view
Oh,
to the camera.
there we go.
Okay. You can hear me, see me? Okay, perfect. So what's happening here at the lab is a bunch of things. We recently got in some new equipment in our quest for anti-gravity research, and that includes this new drill press over here. The old one was way too wobbly, and it's already been sold on Facebook Marketplace to somebody who needed it. And right here we got what's called a spin lathe. Now, these are very uncommon beasts. It's almost a dying art of pressing a piece of metal against a mandrel, which is this in this case, and forming it into that shape. So this would be a saucer shape. Here's an example of something that's been spun, not by me, but this is metal that has been spun. And as you can see, get that flying saucer shape. You need a spin lathe to do it properly. And one of the interesting things that happens when you spin metal like this, the way the electrons flow through the material changes because the crystalline structure is warped by the spinning motion. Over here, we have some of the tools that are used for spinning. It's basically just a block of metal and you press against it. Back over here is another form. This one has a little bit that can rotate with the metal as it's rotating. And here's some of our early fuck ups, and they came out pretty bad. That was before we watched the instruction video.
No one going to comment on the fact this guy has Captain America shields just littering this workshop.
And calling them like fuck ups and garbage, right?
Yeah, he's just like flinging about vibranium, like, it's another mistake.
You need a decal maker to go along with that, Mark, so you can, for your son, give him the helmet and the shields.
Any fuck up that doesn't result in someone getting hurt is fine by me.
Can I actually have a Captain America shield, please, Mark?
Yeah, you can have one of them if you come to the lab, though.
Where's the lab? Is it?
New Jersey.
SpaceX is in Hawthorne, California. We are in Hawthorne, New Jersey. We're the SpaceX of the East. And we are looking towards space in a different direction. We're trying to get to Mars, but without rockets. And trying to make rockets obsolete through anti-gravity.
Okay, so this is my new GoFundMe. Get me to New Jersey so I can have a Captain America shield.
Right? And
you know what? Here's the great.
Put Luke to work at the lab. Absolutely.
You can make the Captain American shield yourself.
Oh, yeah. I want to make my own shield.
You make your own shield on the machine, okay?
Question: can you use those like fuck up ones and like remelt them into a alloy, like add some bismuth to the aluminum and copper, stuff like that?
But we have something better to do with them. We're going to be going to a I'll get to that in a little bit. We're doing a fair this summer. So here is our other lathe that was set up within the last 2 weeks. This is a metal cutting lathe. People are more familiar with this type of lathe, it just rotates and then you come in with the part and cut it. We're middle of making a fitting for our high vacuum pump. Unfortunately, it did not come with the right fitting, so we have to make ours out of brass, and that is what we are going to do. And just lying on the floor over here is something just arrived. This is a 10 megahertz to 20 gigahertz signal generator. This thing, when it was brand new, cost more than a house. I mean, when it was new in like the early 2000s, probably cost over $100,000.
That is absolutely amazing and super jealous. And that's one of the main topics that we want to discuss is signal generators and putting them through different coils. And that is what Mr. Matthew Reif is a specialist in. And that
we're doing something different with these. We're not putting them through.
There's many things to do with them. I want to use them to put into my electrolysis electrodes.
I think the real amazing thing is that you could buy a house in New Jersey for $100,000. Fucking hell! In England, that would get you a very lovely cardboard box.
Maybe 20 years ago when this thing was new. Yes. And the dollar was worth a lot more. This is
Before
a pile
2008.
This is a pile of wood that all this equipment came in pallets, and we chopped it up into firewood.
So that's for the summertime bonfire, springtime bonfire.
Yeah, that when fire pit season comes around, we're going to be ready for it. So that's pretty much what's happening here with new equipment. Now the signal generator that I showed you earlier is for our dynamic nuclear orientation setup. We're trying to orient subatomic particles by a process called dynamic nuclear orientation, which is essentially electron paramagnetic resonance, but with a little tweak. It involves two components: a standing magnetic field, which is provided by a massive electromagnet, which is inside of our Faraday cage over here. You see that electromagnet, and then that provides the homogeneous magnetic field. There's our logo. And then the RF comes in perpendicular to that magnetic field and perturbs the valence electrons, which are processing based on the strength of the magnetic field. So the stronger the magnetic field, the higher the frequency of their precession. And when you get those both in perfect tune or just out of tune with each other, you're able to change the spin of the electron, and through the hyperfine coupling that connects the electron spin to the core of the atom, you're able to tickle the core of the atom and change its orientation and slowly build up nuclear orientation in the subatomic particles which make up the core of the atom, which we believe would make matter weightless. And that is what we're trying to accomplish here.
That's pretty epic.
Your name really checks out because everything I've seen so far is so cool.
It is so cool, yeah. It's literally my last name. Sokol also means Falcon. This is some of the waveguide equipment, and there's a test chamber. Right now we have it pulled out because Jesus was here earlier. Literally, the guy's name is Jesus. And he's going to help us with this problem that I've had. So when I first made this, got this experiment going, people were telling me I should automate it because it's going to take a long time to turn the knob to change the magnetic field. Because you don't change the RF, you change the magnetic field in these experiments in order to, find that resonance point. And I thought, that's so stupid. Why would I need somebody to make a complex system to help me turn a knob? But then I started to turn the knob. And it turns out in order to go through like the entire range of magnetic field profiles that you want to go through, takes about 2 hours. And that means you're turning these tiny little knobs over here for 2 hours while staring at the scale readings, and your eyes start to water up and it becomes very hard to pay attention. It's kind of like watching grass grow, but in the winter.
It sounds like bleeding eyes at some point.
Yeah, it's not fun at all. I've done it for many hours, and I have lots of video evidence to prove that. I haven't posted any of it on YouTube because it is
so. Mark, one thing we can do in the future is I'm going to be doing like a 48-hour weekend, just science streams, and on the very least starting them on my Twitch account, as well as like combining some of my electrolysis ones, different like long range settling things and time things, etc. that we can work together, that if you want them recorded and up, you can be featured on some of them, no problem.
If we're doing something like that that's that long and there's other things going on, I could probably do a live stream with you, while we're running an experiment, because they're so long and they're so boring. Like, you can just have something else going on at the same time.
Right, and I'd like to set up also like a 3D printer like workshop section with some of the guys. Like Faraday's doing it a lot. I believe, Matt, you've got one there too. They're essential in this field, and just for any builder, inventor, engineer.
Yeah, I have like 8 of them.
Down in the back room over here, we actually have a 3D printer that's printing another one of those big. Let me see if Wi-Fi will make it.
Come on, Wi-Fi.
Only 12 hours left. And there's a sneak peek of the gravity diode machine. Okay, so this is the big that I was talking about earlier. Guys, if you're going to be in the New Jersey, New York area in the summer, June 3rd or June 4th, there is a UFO Alien Fest street fair in Pine Bush, New York. And we are about an hour's drive from Pine Bush, New York. So we're going to be setting up shop there and bringing a lot of our smaller experiments, including the cryogenics. We're going to have the liquid nitrogen, superconductors, gyroscopes. We're going to have different presentations of live experiments.
Mark, we lost your camera.
And here's one of the cool things. We're going to have, like those wheels of fortune where you can like turn it and get all different options. So we're going to have one of those. And for a minimum donation, you get to turn the wheel. And we're still figuring out what all the options are going to be. One of them is going to be Jeremy Reese plays a song for you. You get one of our lab fuck ups, like I showed you before. Those
3D prints. Oh yeah. The shields, 100%.
Yeah, you get one of our one of our failures. Well, we're gonna save them, bring them there, and you get the.
None of them are failures. They're just tests.
They're failing forward.
Test runs. Yeah, exactly. Test samples.
Sacrificial.
Just more shields for me.
Whatever you want to call them. Oh, and we're gonna have one spot on it. It's gonna be called osmium or bust, and you have to hit it 3 times in a row, and you get an ounce of osmium, which is one of the rarest metals on Earth. So
it's wicked, man.
Can I be like a guinea pig in one of your anti-gravity experiments?
I don't know if you want to be really.
Yeah, one of the first test pilots.
Yeah, for real. Can you just stick me in one of these chambers and just do some magic?
We'll lock you away in a Faraday cage.
That might be the only way to stop me.
Yeah. Are we going to set up that GoFundMe so you can come down here?
If anyone's watching, go. I'm sure Hippie is lurking somewhere around here, and she'll post my links to my Cash App. And if enough people send me money, I'll buy the ticket right now. In fact, I'll pack my bags on live stream and get the plane. That's how dedicated I am to getting this shield.
Just for the shield. Well, it's June 3rd, so we got some time. We still got a
Also
couple
the
months.
gravity stuff, but you know, the shield really, but you know.
He wants a shield. Okay.
Yeah, I'm here to talk about your groundbreaking achievements, and also I hear you have a shield. You grifter league. I just want that shield.
Right, drift
I
and-
want that goddamn shield.
I think it'd be if you want the shield so bad, maybe you'll get one shipped one day. One day.
Oh,
that
got
shit
knocked
looks so
back.
official though. Like literally, it looks like you throw that about. I bet you do. And when you're not on live stream, I bet you're throwing those things around the workshop, aren't you?
I don't know. The edges are probably sharp.
Yeah, they're probably pretty sharp. We have a lot of stuff going on actually at any given time here.
He says probably as if he doesn't know. He's like, yeah, it'll cut through a wall. I mean, maybe.
They are pretty sharp. They're about as sharp as scissors.
Ooh.
Spinning, flying at you. Not
Right,
the
who
right
wants to
distance
see
you
me
want.
lose some fingers trying to catch one of these shields?
Oh yeah, between the two lathes, the spinning one is by far the more terrifying of the two. Just
Well,
because
yeah,
of the
I'm not going to
radius of
stick my
that thing
fingers in some
spinning around.
lathes. I mean, that just sounds ridiculous.
Oh, I got some questions. Do you got mass spectrometer down there?
I mean, wait, how much is
Oh,
shipping
we
from
lose
New
Mark.
Jersey? Maybe we're doing the wrong thing. How much would it cost to send me a Captain America shield? And that is presuming you can't just launch it and watch it fly across the Atlantic.
Portal it over the Atlantic.
Well, that's the point, isn't it? That's the true test of the shield, you know? Just
Then it's a real Captain America shield.
exactly. You know, fucking first class. See ya.
Yeah, it needs to like go out into outer space and come back in and
So yeah, Mark, do you have a mass spectrometer run at your shop there? Do you do mass spectroscopy there?
Masscopy. No, we do not have one of those here. But we do have a clean room, and inside of it is a vacuum vapor deposition machine. So basically, vaporized material inside of a strong vacuum or a good vacuum, and the material then falls onto a plate substrate where you can deposit various materials. It has two separate heating baths, so you can do two metals at a time, where you can layer them, you can alternate. So one of our last experiments, we were doing bismuth and magnesium, and bismuth again on top of these Lyra, the beetle wing things. And Jeremy Reese is posting that on Twitter as our latest attempt at metamaterials.
The bug. What's the name? It's on the tip of my tongue.
Lyra is the outer cover of the beetle.
Oh, the outer cover. Okay, not the inner.
That's our vacuum
Good
vapor
nuts.
Right there. So that's pretty much what we have going on at the lab right now. And maybe I'll tune in next week and give you guys some more updates when we have some spun metal and some more experiments going on. But I definitely wanted to hit you up with that.
Absolutely. And when you're spinning stuff too, always down for watching stuff spin and coming up with ideas with that. And
before you go, can we please see the Iron Man suits?
Iron Man suits. Oh, are you talking about the silver ones?
Yeah, we know you've got them. Don't you sit there and pretend you haven't.
Okay, so these are lead. That's for hard radiation. But for electromagnetic radiation, we have something really special. And this is you're not going to find anywhere else because these were handmade by a friend of mine. Check this out. This is literally a silver hoodie that goes all the way down. And this will protect you from
The man's got mithril.
I was
Yeah,
gonna make the joke, but
it brings up the
Fucking Bilbo
question of,
Baggins over
was
here.
there more
He's
to
got his
those
mithril vest.
the old full metal suits? Like, you're in a fully encased Faraday cage.
No, I love it. He's like, look at this silk. You wear this, you're protected from anything, heat, a dragon, anything.
Well,
If it got hot, you'd be screwed.
many ETs were seen wearing something that looked very much like this, like a metallic jumpsuit.
That's true, Mark.
And the most sane, logical explanation for it is, yes, they were wearing like literally this kind of material for the very reason that I'm wearing it, because their ship emits RF that can harm.
Radiation that they're having to have blocked in. Yeah, that makes a lot of sense.
It's RF radiation. It's high gigahertz because their ship emits those frequencies because it's using a similar technology to the stuff we're trying here at the lab.
So, I mean, in a really simplified way, it's kind of like flying a microwave and you're on the inside.
Exactly. But if you have to...
It's like, exactly. You don't want that, but that's exactly it.
That's pretty much it, yeah. But you don't want to be on the outside of that close up. Most people who have had close encounters with those flying saucers, like really close, have ended up with burns.
What's really interesting about that is if you go into the Ark of the Covenant story, so you know what, you were wrong. This did connect, right? When you look at apparently the Israelites that left Egypt, they followed the cart, and what they actually followed was a cloud. A cloud guided them, and when it stopped, they stopped. And this cloud apparently at night it emitted lights, and they were warned to not go near it, and people did go near it, and they got burned. And
what it's called is the Amud Anan v'Amud Eish, a pillar of fire and a pillar of smoke. During the day, it looked like smoke, and at night, it looked like a fire because it was a cigar-shaped or pillar-shaped flying saucer that Jehovah, the extraterrestrial, aka God of the Israelites, was flying in. And they used some anti-gravity force field to split the sea. And one really cool thing from that story is the Egyptians were shooting arrows at the Jews, and those arrows came flying right back at them because the spaceship was in between. So there was some sort of force field going on there. But during the Vietnam War, at the demilitarized zone, the same thing happened where they were shooting at a flying saucer that had gray aliens on board. They could see them through the portals with the large eyes. You know, it was just about less than 100 meters away. They shot at it with their guns, and the bullets came flying right back at the U.S. servicemen, killed some of them, and ended up capsizing the boat. And it was their bullets that were coming right back at them. But here's the craziest thing. Fast forward to 1995, in the 3M plant in Pennsylvania, they were unrolling rolls of plastic, which created a very large static electric field, and the same force field was seen in the equipment. Anything you threw at this force field would come flying right back at you. So, Scotty, power to shields. That's how it works.
That book also has sonic weapons in it, where they level an entire town after going all around it.
Yeah, exactly. That is I was just about to bring that up. Actually, the Ark of the Covenants. Well, as well, you've got to imagine. I think this is my view on that Ark of the Covenant thing is that it comes from one of the pyramids. It's kind of like your power source to that unit, and the Ark itself is kind of like perhaps even just symbology wise a reference to the technology, because it's kind of like Prometheus with the fire that comes from God, the gift from the gods to man, and it kind of is that the Ark itself could be that gift of technology.
And the old the tab that the 10 Commandments that were put in there are probably like some advanced technology, and when we finally are able to find it and open it up,
Well, so one aspect I always find fascinating is that the Ark of the Covenant is the exact same measurements as like the king, what they call the tomb or whatever, where the casket was supposedly in the king's chamber in the Grand Pyramid. So it's like, was the Ark of the Covenant the thing that powered the pyramid?
the Ark of the Covenant was what was made by. It was made at the base of Mount Sinai, which is in Saudi Arabia. Double L laws. All of the gold and silver that the Jews got from Egypt was put together to make the tabernacle. I forgot the goldsmith's name that made it. But it was back in those days that they made it. It had nothing to do with the pyramids. And there's different reports that either is in Jerusalem or it's in Ethiopia. But people who got close to the Ark of the Covenant suffered radiation burns, or they died of mysterious illnesses. At the latter days, the final days of the first temple, many of the high priests were dying when they would go in there. And there probably was some sort of radiation poisoning that was happening, like a lethal dose of radiation. So the technology eroded probably over time and eventually started leaking radiation sometime after Jehovah the alien died.
A fun fact for you guys is actually the Ark is
Mark,
in
do you want to
Wales.
close your phone and come back on your computer? And or did you want to stay on your phone, Mark?
Yeah, you can shut the phone off now.
Yeah, but what I was
then,
going to say is
Matt, did you
Wales
want-
is actually the source of the Ark of the Covenant now. So there's a place called Yunus in Wales, and the connection here is if you go to Egyptian hieroglyphs, you can actually